Hello friends, welcome to Edwiki Learning channel. Please do subscribe to get more updates on the DevOps concepts. This video is part of the full course AWS DevOps Practitioner training. Please do check the description below to get the link for the complete full course. Without further delay, let's get into the video. Thank you. So getting into our story, right, what is that we are trying to target, guys? Just as a quick recap note, right, we are trying to deploy a web application in our AWS EC2 instances, whereas the web application should be a highly available and highly secured and auto scalable application, correct? We are trying to achieve these enhancements, these best practices in our application. As part of that, right, we are deploying our instances into a private subnets to ensure the security part, and we are deploying or we are integrating the load balancer to ensure the high availability and load balancing, and we are using the auto scaling group concept to have the auto scalable solution for our application, just to do the scale out and scale in automatically based on the business load. I would say the when the users are more, automatically it will try to do the scale up and scale down in association with the CPU utilization, right, as a metric that it is actually monitoring. Are we good with this statement, guys? That's what we are trying to do, right? And we have already done the enough discussion about the architecture and how this is going to be working. And today, let me go ahead and do the implementation, whereas I'm going to deploy this whole auto scalable infrastructure stack in AWS, right? As a basic building block, the VPC, right? The VPC is still there, right? I did not disturb that. So the VPC that we created in the last lecture, the VPC, the corresponding subnets, and the the route tables, everything is there. So now I just need to go ahead and start creating the auto scaling group and the load balancer stuff. Okay, so get to start that. Okay, so I have already created a launch template. It's the same launch template that we created the other day, whereas the launch template will take care of right launching the server and running the corresponding user data script to bring up the server as per the requirement. In this case, right, the launch template will take care of bringing or configuring your server as a web server and configuring the required coding, whatever it is, right, to make it available. Super. So let me go ahead and start creating the auto scaling group first, right? So if you see here the auto scaling concept in our EC2 service itself, right? So let me go to auto scaling group concept. And before that, I think I'll come back to the EC2 dashboard and I will show you that so far there are no EC2 instances running on my region. And I'm not going to create EC2 instances manually this time because I'm expecting the instances to be managed by the auto scaling group, correct? So now I'll just go to the auto scaling group concept, right, and click on create a auto scaling group, right? It has almost 7 steps that I need to fill up the form to deploy the auto scaling group, which is the group of EC2 instances that you would like to have, right, for your application. Well, let me start filling this form, guys. So the first thing is I need to give the name of my auto scaling group. It can be any name that you like it. Now you tell to auto scaling group that which launch template that it has to use to deploy the servers as part of the scale out operation. The launch template was already created, right? You can see that launch template in the drop down here. Just select the launch template and it automatically populates all the EC2 configuration that you have given in your launch template, guys. Good. So now go to next, right? And it is just right asking you the details. Like you are expecting the auto scaling group has to be created in which VPC. I wanted it to be in my customized VPC, web VPC 01, and let me choose the availability zone and subnets. So what is that I need to choose here, guys? The public or the private subnets, right? So I'm expecting the auto scaling group should deploy the EC2 instances in the private subnet to have my servers are secured, and it's always recommended to use at least two different subnets of two different availability zones, so that the servers will be get deployed it into multiple zones to get a high availability even in case of the zone failures as well. Most of the things we already discussed, I'm just going through them now to get this implemented, guys, right? So go to next. Now it is asking you that, hey, this auto scaling group should be now tied with the which load balancer for distributing the traffic. So at this time, either you create a load balancer first or you create a auto scaling group first, correct? Since I'm creating auto scaling group first, at this time I don't have a load balancer to select it from the list. Hence the reason for now I will choose that, hey, I don't have any load balancer at this time. First let me create a auto scaling group, right? Then I will come back and select the load balancer. I will edit the auto scaling group later part. At this time I don't have load balancer and I'm going with no load balancer for me. Okay, now just go down, let it be these default options, and let it be all the defaults, guys, for now. Go to next, and this is where it is asking you that hey, what are the auto scaling group size that you are expecting, right? Yeah, so you see here, so I'm expecting the minimum one and maximum. You can say maximum is like 6, minimum I would say you can go for 2, even you can go for 1. It's up to you. We already know the concept, right? So how many number of minimum servers that you are expecting, you define that as a minimum, and the maximum number of servers that it has to do the scale out, and it has to start with what will be the number of desired capacity. That means, so hey, start with one server for me, right? We can just fill up these forms. Now you see that no scaling policies in the sense, right? It will not do any scaling for you. Okay. If you're expecting the scaling to be right, then enable the scaling policies and tell that, hey, auto scaling group, I want the scale out to be done right based on the metric type. As of now, the auto scaling is supporting, there are only 4 metrics that are supported, right? So based on CPU, based on network, and based on the number of requests that you receive from the application load balancer, right? Which one you feel more um, um, good way to configure the auto scaling, guys, right? So usually average CPU utilization is the better way to configure it, because I don't care how many number of requests are coming in. At end of the day, what I care about is my EC2 instance should have enough capacity, enough compute capacity to handle the request, right? As long as your server is not overburdened with the more CPU, this is good. So I'm going with average CPU utilization as a metric. Whenever the average CPU utilization is more than 80%, please do consider that as a threshold limit and go with the uh, uh, a scale out operation. That's what it is, guys, right? Whenever you choose the average CPU utilization and the corresponding threshold value, it is going to create a required CloudWatch metric it is going to create a CloudWatch alarm automatically for you for this specific cutoff value. I'll show you that CloudWatch alarm once it is created after this operation, right? Now just scroll down, and these are all like the defaults for now, let it be guys. I'll talk about them. Now, I don't want to make it more complicated by discussing everything in one single shot. That's only the reason. Okay. So now let me come down, and this is just a maintenance policy. Let it be all default. Let me go to next. Let me go to next. Let me go to next. This is just a review, and I'll just go down and click on create a auto scaling group. So let me click on the auto scaling group guys. Let me verify the subnets one more time because I see a chart window that I have selected a public subnet somewhere. Okay, I'll just try to confirm it one more time. I'll just go to the network section one more time just to see. Yeah, you see here there is a one public subnet is selected. Thanks for that. Let me choose the private subnet here. Yeah, it's updated. Yeah. So this is the auto scaling group that I just have created. Now, if I go to the EC2 dashboard, now you see that there is one instance that is currently deployed, which is currently initializing. Okay, and let me see the details of this instance, guys. Right, it is deployed into a private subnet. I see the private IP address here. It looks good. Okay. Now, as of now, the auto scaling is completely done. Now the time for me to go and create a required target group and the corresponding load balancers, right? So I think before I go there, maybe just to get your understanding here, okay? What will happen, guys, if I terminate this EC2 instance? I just have terminated a EC2 instance, and if I look into the auto scaling group here one more time and see the behavior of the auto scaling group, right? As of now, who created this EC2 instance, guys? I did not created a EC2 instance manually, right? The instance is actually created by the auto scaling group. So it's auto scaling group responsibility to ensure that it is always running with the minimum number of servers, right? Whenever it sees that the, if I go to instance management, you see one more server is coming up. Maybe if you go to the activity section here, you see the activity, guys. Since the server is got terminated and it is actually launching a one more instance for you automatically because it has to maintain one minimum server for all the cases, right? That is the other advantage having the auto scaling group. So for any reason, if your servers gets terminated, right, it will try to recreate it again and it will try to maintain the minimum servers always, and it will do the scale up, right, based on the CPU alarms that we have been configured, guys, right? Good. So now I'll come back to the target group section because once auto scaling is able to maintain the number of desired EC2 instances for your web server purpose, in order to distribute the load to those servers, right, we need to have the target groups and the corresponding load balancers, right? So let me come to the target group section first. Let me create a target group. The targets for my target group is instances. Let me select that option. The target group name, let's say TG01, right? Since the EC2 instances that are currently deployed in my auto scaling group are configured as a web server listening on port number 80 to serve the web traffic, I am configuring the target group also to listen on port number 80 only here. And let me select the VPC in which VPC the target group has to be created. And we are already familiar, right? The health check process. So let me go with this default health checks and go to next. So here I don't want to select the instance and add it to the target group the way how I did it before. The reason is the number of EC2 instances that are being managed will keep on varying based on the incoming load, right? The auto scaling will decide the number of servers to be running as 1 or a 6 or in between the 1 and 6. So since the number of servers are not static, I'm not going to add any EC2 instances manually to my auto scaling group. I will create a empty target group without adding any EC2 instances to that. Currently, the target group is empty. It doesn't have any EC2 instances, guys. What I do is, once the target group is created, I can go to the auto scaling group and I'll inform to auto scaling group that, hey, this is the target group that has to be associated, right? I will go to the auto scaling group one more time and let me edit it. Edit the load balancing section. Now, my load balancer is application load balancer, and select the target group from the drop down here. Now just click on update. Now your target group can identify the number of servers that are there in the auto scaling group, and it will register those instances as a targets. If I come back to the target group and look for the target group again, let me refresh. Now you see that there is one instance automatically identified in the target group, and currently it is unused because the load balancer is not yet created and attached to the target group. Now the time to go to load balancer section and start creating a load balancer, right? As we are working on the application load balancer for now, let me choose application load balancer, which is capable to listen on HTTP and HTTPS traffic actually. For now, let me create it. The load balancer name, let's say LB01. I'm expecting the load balancer to listen on internet traffic because the end users are actually sending the traffic to the load balancer directly from public internet space. Hence, I'm choosing internet facing here. Now, let me choose the VPC in which VPC I would like to deploy. Let me choose the corresponding availability zones, and you all know, right? It should be a public subnet because the load balancer should listen on a public traffic, right? And let it be the security group, and of course we need to ensure that the security group is actually having the inbound rule to allow the traffic on port number 80. In the listener configuration, this is where we need to tell that, hey load balancer, you listen on port number 80, and that traffic should be get forwarded to the target group, and you specify the target group here, which target group should get a traffic. That's it. Now just scroll down and create a load balancer. View the load balancer, right? So let me open the load balancer. It is in the process of provisioning at this time, right? And we can see the DNS name. The DNS name is something important that we need to use to access the load balancer. And this DNS name, you can configure a CNAME record in the Route 53 if you wanted to access this load balancer using your customized web domain name, right? Most of the things are repeated, but I'm just trying to put together all the topics that we have done so far, right? So now I'll just go to the Route 53 and I'll choose my hosted zone. the record is already exist, right? Because we were keep on doing the exercises on this. Let me edit the record. www.edshopper.com should have the CNAME record and pointing to my new load balancer endpoint, and save it. Good. Now I'll come back to my EC2 one more time because I wanted to verify that the target group is healthy, right? So let me go to the target group and refresh the target group one more time. This is my target group. Currently the server is unused. Let me refresh. You see that it is trying to initialize the target by checking the health status, right? So the Route 53 hosted zone name servers must be updated in the domain registrar like a GoDaddy in our case, but that is one-time activity. We don't need to do every time, right? So when I did it in very long back, it is already set up. So I'm just editing only my custom resource names in my hosted zone. So the name servers are already set up. The name servers are not going to change every time, right? So that is good enough. Now, good thing, you see that the instances became healthy because as part of the launch process, the user data is already took care of configuring your server as per the need, and the web server is already configured, right? Now, if I try to access this application, maybe www.edshopper.com, that's it. You see that your website is live. What is that you understood from the today concept, guys? The thing is, slowly if you observe, right, without me logging into the operating system, I'm trying to fully configure my server as a web server and make my website visible, accessible to the users, correct? Did I log into my OS? No. Did I run any commands manually? No. So I'm trying to offload that operating system configuration steps completely, and I'm trying to make it towards the automation side of world, guys. Agree with me? Well, so now the thing is, what is the case if more number of users are accessing the website, the CPU utilization will go high and it has to do the scale out, right? So let me see all those exercises just to get a confidence that the scaling is working as expected. For that, if I browse through the CloudWatch one more time, because I said that the CloudWatch alarms will be created automatically, right? If I go to CloudWatch, right? So if I go to CloudWatch and let me look into the alarm section here, guys. Okay, you see that there are two alarms are created automatically for you. Okay, there is a one alarm, the alarm which is with the threshold of 80. You see, whenever the CPU utilization is greater than 80%, okay, then the alarm has to be triggered. Alarm in the sense, currently the alarm is showing the state as okay. Help me guys to understand, for this alarm, what does it mean by the state is okay? Okay in the sense, the condition that was set here is greater than 80, but the current utilization is less than 80, correct? As long as the real usage is not more than the threshold that you given, you are good, right? So that's where it is saying that, hey, the alarm is in okay state. Okay, so whenever the utilization go beyond 80%, this particular okay state will be turned into a alarm state or a red mark. Then it will, this alarm will go and inform to auto scaling group. Auto scaling will take care of doing the scale out operation for you. That's how it works. And you see there is a one more alarm here, the second alarm, which is configured for less than 72. That is still fine. It's the AWS is automatically configuring. It is not exactly less than 80%. It took care of less than 72. That's fine. So whenever the usage is less than 72, then it will consider that, hey, look like the load is very less. Maybe it has to do the scale in operation. That's how there are two alarms are automatically created for you based on the threshold that you configured in the process of creating a auto scaling group. Are we good with this? Now, in order to test, maybe I just done the refresh, guys. Sometimes you see that the state showing as insufficient data, that is still be fine. Usually, sometimes it will show that insufficient data. Whenever the CloudWatch is not able to get the CPU utilization of your EC2 server for any reason, you getting me? The CloudWatch is the service which has to go and connect to EC2 and get the required CPU utilization and compare with the threshold that you given, right? If your CloudWatch is not able to get a metric from the server, then it doesn't know what is the real usage and it cannot compare with a threshold as well. That situation is considered as a insufficient data, correct? If you don't know what is the right value and you don't know how to compare and how to take a decision, right? So insufficient data is mean that whenever it does not have the enough information to decide whether it is in OK state or whether it is in alarm state, then it will show insufficient data. Maybe the very first time when you created an alarm, sometime it will be showing as insufficient only because it takes some time to go and get the data, compare and decide what is happening. That is still be fine for now. After some time, definitely this will be get turned into right OK or alarm, whatever it is possible. For now, in order to validate the scaling or scale out is working as expected, what I do is I'll go and start putting some load on my server, guys. Okay, there are different ways are there in order to put the load. In order to get a real load, okay, how do you get a real load, guys? So if it is a real-time environment, whatever the website is there, the users whoever wanted to do the shopping, right? Those users will come to my website, they will purchase the products and all. So that's how the real traffic come. But here I can't test it, right? If a lakh people are accessing my website, whether the auto scaling is really scaling up or not, how do I know that? Correct. So we can do the simulation by manually putting some stress on the CPU. Hey, I'm putting some more load on the CPU so that the usage will go high and we can test it whether it is working as expected or not, which is called as a load testing, guys. Okay, load testing is the terminology that we use. There are different ways are there to put the load testing on the server, like putting the dummy load on the server and verify how it is behaving, right? The simplest, easiest method to put some load on the server by making it more CPU consumed is by running the stress command on the server. So let me connect it to the server to show you the command that we need to run to put some dummy stress on the CPU. There are many different ways, guys, but this is one of the way to put some load. Right, I just logged into the server and this is where we need to run the command called stress. Okay, for now you see that the stress command is not found because that is not as part of the operating system. Even if you try to install the stress package to get this command available, this is interesting. The command is available for you to install from the default Amazon repositories. Good. Let me accept it. In the sense, the stress package was not available in the default Amazon repositories in the previous versions, guys. That's where it is. Now it is available as part of. That is good. So just run the stress command. Usually if you are not running the command with the proper syntax, it will give you the error, right? I'm getting this error, so that I'll get the example here. You see the example, copy the example. Now let me run the command again. So this command is actually putting some load on the CPU, and how much time that you are expecting the load to be on the CPU. That is what you can see the timeout here, the value in terms of seconds or minutes or whatever it is. Since already there is a seconds, I'm just putting some more seconds. That means the stress command is now putting some load on the CPU for this many number of seconds. The usage will go high. You can monitor this CPU utilization from the CloudWatch as well, because we know, right? The CloudWatch is keep monitoring your CPU metrics. So I wanted to monitor the CPU, right? I'll just go to CloudWatch. I'm just trying to do the simulation here, right? I'll just go to the CloudWatch. Now here you can see all metrics. I wanted to look for the metric. Let me search for the EC2 server that I'm interested on. Now you can see the CPU metric of this EC2 server. Select the CPU utilization metric of the server. You see the server is just deployed, right? That's the reason you see that data started off just now. I wanted to know the utilization since last 1 hour, right? This is how it is. You just wait for some time, then the usage will go up. So maybe I'll go for last 15 minutes. Yeah. So currently it is like 16%. So usually it takes some time, guys, okay, in order to get the utilization and show it in the graph. If you wait for some time, then it will show that the usage is almost 90%, right? Then the alarm will trigger and auto scaling will kick in, right? So in other tab, uh, I wanted to keep my auto scaling group open just to see the behavior of the auto scaling group, right? You can go for the activity tab of your auto scaling group and you just look at this. Whenever it is trying to create a new server, it will give you the information here, right? In other tab, you keep these alarms open. You see, guys, greater than 80% alarm is currently showing okay. Is that expected? Correct, no? Right? The greater than 80% is showing okay because current utilization is not beyond 80%. It is still coming up. Okay, it takes some time to fully come to the 90% utilization, right? That's why it is okay. What is the current utilization, guys? As per the CloudWatch, it's almost like 60%, right? That's the reason if you look into the alarm, CPU utilization less than, that is currently in alarm state because it is matching to this alarm. Previously it was less than 72%. Now it is auto adjusted to 56. That is still be fine. That's the AWS will calculating, right? That scale in threshold for you. If you wait for some time, the greater than 80% should turn into alarm state, right? And this should go to OK state. That's how it will be changing. It takes some time. Whenever the alarm which is configured for greater than 80%, if that alarm state is turning from OK to alarm state, that means hey, there is a high usage. Then it will go and inform to auto scaling. Auto scaling take care of doing the scale out for you. All the magic will happen. I'm just keeping multiple tabs open, guys. Because I went with the defaults, okay, it is taking some time. Basically, we can configure the data points here. You see the data points here, guys. So this data point will tell how much time that it takes to get the data and decide the state of the alarm is okay or in alarm. Okay, so which is like almost 3 minutes at this time. So we need to wait for at least that much time to 3 minutes and three data points. I think it's almost like maybe 5 to 10 minutes, something like that. Okay, that's fine. We'll just wait for some time. It's already doing something. The alarm is currently in insufficient state, and you see that it is already in alarm state. Let me come back and see the usage in the CloudWatch one more time. This is still at 17. That's okay. Let's see. I think I have already shown you the command that we need to run at OS level in order to see the CPU utilization, right? I can't run the commands because my stress command is running in the foreground. If I need to run the one more command, I need to take one more session, guys. Anyway, we are waiting for this, right? I can go to the EC2 and get a one more shell to run the top command over there to see the usage. Basically, the CloudWatch will take some time because if you run the command on the Linux side, OS side, immediately you will see the usage is more than 90%. But the CloudWatch will not be detected immediately, right? Because that's the AWS service. It takes some time to go to EC2 and get the metric, compare the metric, and show the status in alarm. So it takes some time. So the stress is running over there. This is my other terminal and where I'm running the top command. Now you see that the top command in my Linux side is showing that there are multiple instances of the stress command is currently running on the server, correct? And you see that the stress command is actually consuming 7% of the CPU. Each stress instance, almost there are 8 stress commands are running just to make more load on the processor, and each instance is almost 7%. It close to a lot. Okay, and even if you see the CPU utilization here, guys, what is the ideal at this time? Ideal is showing 0. That means what? When the ideal is 0, the usage is almost 100%, right? That's how we can see the details. Let me come back to CloudWatch one more time and let me do a refresh, and now we see that the usage is showing almost 100%, correct? The usage is went up. It touching 100% almost. Good. Now if I come back to the alarm section here and refresh the alarm, you see that it is already done the toggle. The alarm which is greater than 80% is now showing in alarm state. That means what? Hey, the usage is more than 80. Look like something is wrong, and it is turned into a alarm state. It will inform to auto scaling. Now auto scaling will do the necessary action for you. If you come to the auto scaling now and just do a refresh in the activity section, now you see that it is actually launching a one more new EC2 server. How it is doing? It is actually updating the desired capacity from 1 to 2. If you look into the details of the auto scaling group, now just refresh. I'm just doing the refresh here, guys. Right? You see now the minimum is 1, that is fine. The maximum is 6, right? But what is the desired now count? Sometime back the desired was 1, now the desired is 2. Why? It is identified that the usage is more, and now we need to spin up one more server, and now the desired is updated as 2, and one more server got created. If you look into the instance management, now you see that there are 2 servers that are getting added to your auto scaling group. Are we good with this? Now, if you go back to your target group section one more time, just to see what's happening there. In your target group, now you see that there are 2 instances that are currently added as a target, and both of them are currently in healthy state. Now, the traffic, whenever the end user is accessing the website, right, this traffic will be now get distributed across the 2 servers or part of your target group, which are managing by the auto scaling group. That's how it will balance out uh, the load by distributing them it into multiple servers. When the servers are not capable, not enough to handle the load, it will again do the scale up. So as long as you are keeping the load on the server, it will try to spin up one more server as well. If you wait for one more time, like another few minutes, right, definitely one more server will be get created. There will be 3 servers, 4 servers, 5, 6. 6 is the max. Good. Whenever you remove the load, let's say I'm doing Control C here to terminate this stress command. Now you look into the top command, immediately all the stress commands are gone. The ideal is back to 100%. That means the usage is almost 0. If you wait for some time, the corresponding alarms will be triggered here. It's automatically started off. When it sees that the usage is less, then it will try to do the scale in operation, and it will terminate one of the server and keep only the minimum servers to running there. That's how autoscaling is the concept of maintaining the desired number of EC2 instances all the time to serve your business load. So we are not creating EC2 servers manually. We are not terminating as well. It take care of by the autoscaling for you. You just tell to autoscaling how to do and what to do and the required configuration there, guys. Where are we now? Yeah, it will take care of automatically. After some time, the usage will go down to normal. That's fine. Now, in the CloudWatch, okay. So in the CloudWatch, so far the alarms are actually created automatically by the auto scaling as part of the auto scaling creation process, right? But as I said, you can create your own alarm as well based on your need, correct? Because the CloudWatch is actually monitoring all the metrics. You can see all of the metrics in the metrics dashboard here. Maybe I can remove the filter, right? We can see all of the metrics here, right? So sometimes you may be interested on a specific metric. Which metric that you are interested on, you can create a alarm by yourself. So I'll just go to the alarm tab to create a alarm. Select the metric. Now you select the metric from the list, right? Let's say I wanted to create a alarm for my Route 53 as an example. It's not showing anything. That's okay. I'll just go back to EC2. I need to search for my instance ID. Okay, so maybe I will set up the things differently. You see that the status check failed, guys. We already familiar, right? What does it mean by? So the requirement is I want to know whenever the status check is failed for this EC2 server. You got me? Previously, I talked about that. Hey, status check is something that always should be 2 by 2 or else your server is not healthy state, correct? But how do you know that when the instance will turn out into the status check failed? If at all your server is in the status check failed, you want it to get notified, right? Correct? Hey, can you send me the email whenever my instance is into a status check failed? Hey, can you send me the email whenever the CPU utilization is more than 80%, right? That is how you can configure a CloudWatch alarm by specifying the metric that you are interested on. If you're expecting that kind of the notification to be out, right, you can configure your alarm here. So go to create alarm, select the metric. Let's say I wanted to know whenever the status check is failed, right? Just select that metric. You see here, hey, look for the EC2 instance that I specified. Look for status check failed, right? Whenever the status check is greater than or equal to 1, because if at all the server is healthy, the value will be 0. If the server is not healthy, the status check value will be 1, right? So make it as a whenever the value is greater than or equal to 0, sorry, greater than or equal to 1 is also fine. Then I want it to be notified. Like that, you can create alarm based on which metric that you are interested on and specify the corresponding the condition on what basis or whenever your current value is breaching this threshold value and I wanted to get a notification. So we can create alarm, guys. Go to next. You see here, whenever it is meeting that condition which you have defined, what is that needs to be done? Action. Specify the action item here. The action item can be a notification, can be a lambda, can be auto scaling, can be EC2, can be any other. So for what is been done, we have tested on this auto scaling action, which is automatically configured for you. Whenever you create an auto scaling group, right, it has created alarm for you, and that alarm is created with the auto scaling as an action. That's the reason your auto scaling is able to do the scale up. But not all the cases your auto scaling will be a target action, right? In this case, let's say whenever the instance status check is failed, I wanted to get an email notification, then your action will be a notification. Like that, we can choose which action that we are expecting to be whenever the alarm is in a alarm state. So go to add notification. Now it is asking you more details. Hey, when you are expecting the notification to be out? When do you need a notification, guys? When the alarm is in alarm state or okay state or insufficient state. We know, right, there are 3 type of states that are currently there for a alarm. Just to repeat again, insufficient state in the sense your alarm does not have enough information to decide what is the current usage, whether that is more than threshold value or less than threshold value. Then it will show insufficient date. Okay state in the sense the current usage is, right, the current usage is less than whatever you have been defined in the threshold. That means this is a good condition. Alarm state in the sense something has happened, right? So the current value is more than or it is met your condition, whatever the condition that you define, which is the alarm state. Now tell me, guys, which one you are looking for, which is more interested on, or which one should be get alerted, right? That's what I'm trying to, right? Obviously right? You'll be interested on alarm state because that is what is something is happened. So select that whichever you interested on this. Then you see here that the send a notification to the following SNS topic. What does it mean? The CloudWatch is only be responsible to monitor a resource, get the metric, and compare that metric value with the threshold that you given and decide whether your metric is in alarm state or OK state or insufficient state. That's it. The CloudWatch does not have the capability to send a notification to someone on email or something else. So to get a notification out, we need to work with the service called SNS, guys. Let me introduce you the SNS and then I'll come back to the screen again. We can search for the service called SNS, which is the simple notification service. The SNS is the simple notification service, which is quietly easy service to work on. The service just need a topic. The topic is like you just create a group, right? Or the kind of the team who who would need the notification to be out, something like this. For now, let's say I'm creating a topic. Okay, so let me create a standard topic. Sorry, let me see the difference, guys. You see that if it is FIFO, you see this topic is this is for SQS, which is not recommended. For me, I want to get an email notification. You see the email, getting the SMS, all these are possible in the standard topic. So let me create a standard topic for me because I'm expecting the email notification to be out. Then give the topic name. Topic in the sense basically a group, guys. Let's say I'll say this is a AWS topic. So I'm going to keep all the AWS team members in this topic. That's the goal. Okay. Maybe I can say AWS team. Any name would be fine. Let it be all defaults and create a topic. Once the topic is created, to this topic now you need to add a subscription, guys. Subscription in the sense who should exactly get a email, who should exactly get a notification. That is what is called as a subscription. In this case, let's say I'm trying to use this topic for my AWS team members. So now you add all of your AWS team email IDs as a subscription so that all of them will get a notification. For example, now I'll go and create a subscription. Now the protocol, my requirement is I wanted to get an email, right? Select the email from the list. The SNS help to send a notification to all other services as well, which you don't need to worry at this time. For now, I want to get it in email. Specify the email. Let's say I'm just specifying my email ID over there. Just come down and click on create a subscription. Now you see, right? I just have added one email to this topic, right? Currently that email is saying that pending for confirmation. That is fine. Like that, whoever is interested on to get a notification belonging into this team, I can go and start adding all of the email IDs to this topic. Getting me? That's how topic is basically a group of multiple subscribers, right? Now I can go and create a subscription and add one more email ID and add it to this. That's how it works. But usually when you add a email as a subscriber, right, it will not be get added directly because someone has to approve that yes, this is my email ID, right? So let me do that. If I go to my email inbox, right? You see here, I have received an email from SNS, the first one, which is asking me to confirm the subscription. Yes, the subscription is confirmed. Now, if I come back to here and just do a simple refresh, now we should be able to see that the subscription is confirmed. You see that this email ID registration is successful. That's how it works. I'm done with SNS, guys. You just need to create a topic and just add the subscribers to the topic. That's it. Now, whenever you are expecting the notification to be sent out to these guys, you just go back to your CloudWatch alarm wherever you are expecting the alarm to be created. Now here, just go to select an existing SNS topic, then select the topic from the list. Of course, I need to refresh because I just have created a topic. So let me come back and go next again. You see now the topic is showing in the list. That's it. If you choose this topic, guys, how many subscribers are there for this topic? All those subscribers will get a notification. That's how it works. Getting this? So select the topic. It automatically take care of the email IDs which are subscribed to the topic. Now it will send a notification. That's it. Go to next, and create alarm. You see, I just have created my own alarm here. The condition is whenever the status check failed value is greater than or equal to 1, then please send an email. Initially, it will be insufficient, obviously, right? It takes some time to gather the data. After some time, it will turn out into OK or alarm state, whichever is applicable based on the data that it has been gathered. Like that, any metric that you are interested on, yes, you need to create a specific alarm for that and add your condition, add your action item, what is that you are expecting to be when the alarm is triggered, guys. Good with that. Now coming back to our story, you see, actually there are 3 servers created as part of the auto scaling, right? And when the usage is go down and you see one of the server is again getting removed, it is doing the scale in. Maybe I can go to auto scaling group to see what's happening there. You see, they're actually terminating one of the server because there is no load on the server. It need not to run with 3 servers, right? From 3 it is actually sending it to 2. If you wait for some time, again 2 will become 1. That's how the scale in and scale out is happening automatically. Right? So currently, this is what is implemented, right? Let's say currently I deployed it for at shopper.com. Okay. Maybe now I wanted to deploy a one more website, one more web application, right? So it's up to you. If you want, yes, you can use the altogether a different setup. Like you can create a one more load balancer, one more target group, one more auto scaling group, one more launch template. You got me what I'm trying to? Whatever I did it now for my shopper.com website, you do everything again for another website or another application. Or it is even possible to add multiple target groups to the single load balancer, correct? I think if I go back to my load balancer architecture, a lot of brainstorming will be needed here, guys. because a lot of concepts that I'm putting together. I'm just trying to get the yeah, here you go. Right, so you see here this scenario. In this scenario, right, so each target group is actually containing a different application, correct? How do you achieve this, guys? Right, so that is where we need to update the load balancer with the listener configuration, right? So let me go ahead and do this for you. And I think I don't need to show you how to create a target group, right? We're already familiar. You create a target group and you create a corresponding auto scaling group and you just map to there. So if I go to load balancers, okay, select the load balancer, okay. If you look into the load balancer listener and rules tab, guys, and you see that currently, hey, whenever the usage is, sorry, whenever the request is came to port number 80, please forward that to a specific target group. That is what is the listener rule, right? All what I can do, right, I can just go and click on a, a rule name here. You see that the rule, just click on the rule. Now you went inside the rule. Now here you can add another rule which is called as a listener rule. This is the second rule that I'm adding. So maybe rule 2, add condition. You see here, what is that you are trying to add as a condition? There are different conditions that are available here. Let's say whenever the website is a different one, right? Then I wanted to move to a different target group. So just go with the host header, then say that, hey, if the website is eduyeki.com as an example, right? If the website is eduyeki.com, right? If at all the host header is eduyeki.com, that means if anyone is accessing eduyeki.com, then that request should be get forwarded to so and so target group. I'm not exactly implementing whole the stuff, guys, because a lot of them are already we did it. Okay, that's repetitive. So you keep the a second target group for your second application, and you add that second application in the you select it from the drop down. That way, if someone is accessing eduyeki.com, the request will go to the specific target group, whatever you have been selected here. Getting me? At this time, I have only one target group. Since I did not create another target group, but we should visualize the things, right? I don't need to create one more target group, one more auto scaling group, one more launch template just because of that. I'm just showing wherever the change is there, right? So you see now there are like two rules, right? By default, all the traffic will go to this target group. If at all the incoming request is for eduyeki.com, it will go to this target group. Like that, you can add multiple rules by saying what kind of the request should go to which target group is. That's how, right? One load balancer is enough to understand the incoming URL, and based on that, the traffic should go to which target group out of the available target groups in your list. So in that case, each target group will be mapped to its corresponding auto scaling group, and it has its own launch template to have that specific application to be configurable. If you ask me, are we really using this kind of multiple listeners in the real time? I would say Not really, which is adding more confusion and more difficult to do the management, right? So mostly we are not doing this, right? Since we have a better way to handle in the Kubernetes. Okay. So before the Kubernetes, or whoever is not using the Kubernetes concepts, those people were using this concept, having one load balancer targeting to multiple target groups, multiple listener rules concept. But whatever I'm achieving here can be easily done in a different way in the Kubernetes later part. Hence the reason the people are not actually using this multi-listener configuration concept, guys. But I'm just trying to touch base on that as well, that the load balancer is having that capability to add a multiple listener rules as well. Why I'm not going in deeper to show all this implemented, because this is done in a different way in a Kubernetes later. That is what is exactly a real time. This is not, people are not really using much. Getting me? Now, so what is our goal, guys? Again, I'm keep on repeating just because that is our goal as a engineer. Okay, your goal always is to make sure that your web application is live accessible to the users with the security, high availability, scalability features are included, correct? So we are achieving one by one. We achieved the auto scalability and the high availability, load distribution, and somehow the security as well. But I need to talk about the security a little more. Okay, so maybe I don't have a right slide at this time, or if I have the slide, there are hundreds of slides with me, guys. So let me go with this. So let's say this is your EC2 instance where exactly the web server is currently configured. Okay, now let's say I have the client here who is actually accessing my website from the browser, right? So when the client is requesting for the website, the request is actually coming to the web server, correct? Are we good with this? No matter the request is coming directly, request is coming from target group, coming from auto scaling, sorry, load balancer. I'm not talking about all of them. At a high level, yes, right? When the client is looking for a website, the request is actually coming to your web server. Don't care about who is routing, who is taking care of all this, correct? So if you slowly look at this client to the web server traffic, okay, let's say the kind of the website that it has is maybe a user has to log in. Okay, let's say the client is doing some registrations. You all know, right? If you go to any one of the website, you can do the sign up option and create an account. Once you create an account, you can go for login option and give your username and password and log into the website, correct? All these things can be done. The thing is, whatever you are supplying the information from your client browser side in order to register or login, or it could be uploading a file, anything, all these requests are actually hitting on your web server and the web server is giving the response back, correct? That's how it works. The request data that is being traveled from client to the server, that data is traveling over the public internet, correct? Or public network. That means definitely, to be specific, if I talk about the registration and login related activity that the client is doing from the browser, the username and the password that you are sending, right, to the server, hey, these are my credentials, I want to log into this website. Those credentials are transferred over the public network to the server for validation. Then your data must be secured over the transit, correct? Can I use the terminology called transit? Transit in the sense, during the traveling time, when the data is traveling from the client to the server, right, during the traveling time, which is called as a transit time, your data should be secured. If at all the client is sending this data to the server on port number 80, then that data is traveling as a plain text format and your data is not secured. So when the data is traveling from client to server on port number 80, right, any hacker can come in between and hack your data as well. Basically, they can come and steal your data. They can come and see your data, what username, password that you are sending over, right? They can come and look into your data as well. Don't worry how the people will do. So that's where the smart people can go and hack your credentials when it is going via the network, guys. That is the reason we should not use the port number 80 for any of our web applications, because which is not really a secured manner, because the traffic is moving in a plain text format and everyone can go and see the data. To make it more secured, okay, so rather me using the port number 80, we need to use the port number called 443. Whenever you configure your web server to listen on port number 443, then the web server is expecting the data that is received on the 443 is in the encrypted format. That way, when the client is actually sending the request to the port number 443, the client is actually like encrypting the data and it will be get decrypted at your web server side. That's how, like, overall the data that is traveling over the transit or over the network, that data will be completely encrypted. That's only the difference between port number 80 and port number 443, guys, right? So port number 443 is actually the HTTPS protocol. Even in the client side, so far we know that HTTP colon slash slash, right? So now it should be HTTPS colon slash slash. The S stands for secure. So whenever you use HTTPS colon slash slash, your browser by default send the traffic to the port number 443 and it will ensure all the encryption algorithms and your data will be encrypted over the transit time. That's how your data will be secured. How many of you how many of you know that how the encryption will happen? If you closely remember, guys, we already touched base with this concept, right? Whenever you are expecting the encryption to be happen, right, the client side we need the client side we need a private key. The server side we need a public key, correct? Usually we know this concept somewhere, the public and private key combination, right? So then these two keys will know how to work together. They know how to encrypt it, they know how to decrypt it, because these are the combined combination SSH keys. Then the data will be in an encrypted format. We are going to apply the same logic here as well. Whatever we did previously, like generating the SSH keys, public key, private key, and keep the public key and private key on both sides and use that key to connect the server, right? Same thing I'm implementing now also to make it your data to be encrypted during the transit. The only difference is previously when I have used the SSH keys, right? Both are like a private, right? I mean to say the client and the server both are in your control. But now I'm dealing towards the website traffic, correct? Previously you were handling the SSH traffic, but now this is the HTTP traffic. Getting me what I'm trying to? When I configure the SSH passwordless authentication, right, from source to destination, your traffic is moving on port number 22, correct? But now the traffic is moving over the HTTP protocol on port number 443. That's the difference there and there. So here you can't use the private key and public key that you generated by yourself by using SSH-keygen. No, that will not work. Because the keys that you generate by yourself by using SSH-keygen, right, Those keys will work for you to handle the port number 22 kind of a traffic. But now this is a public traffic on public internet space. So you need to purchase a public and private key combination from the vendor's case. You can't generate by yourself just like that. These days there are sources are there who can give you some free SSL certificates. Now there's a slight change. Previously I was talking it as a SSS keys. Now we call it as a SSL certificate, right? What is SSL certificate? SSL certificate is actually a public and private key combination only. One key will be at one side, the other key will be at the other side. It is mostly handling the HTTPS based traffic to make it more encode and decode and make your data in a secured or the transmission, guys. That's it. So to use the SSL certificate for your website traffic, we need to go and purchase a SSL certificate. We need to buy this. You can buy this SSL certificate from any vendor again. It's up to you. GoDaddy, Route 53, or any other vendor. Like how you purchase a domain name, same way you go and purchase a SSL certificate and use that SSL certificate for your website traffic, guys. Coming back to here one more time. Whenever your traffic is not hitting web server directly, because in between I'm actually using the load balancer, correct? As part of my improvements, I have introduced a load balancer, right? This is my LB. Okay, so this is my LB. And your load balancer and your web server, everything is inside the AWS VPC, correct? This is your VPC. Now tell me, guys, your client request is coming to load balancer. Load balancer is actually forwarding it to your actual web server, correct? Now, where do you need to more worry about the security? Between the client and the load balancer, or between the load balancer and the web server? Getting me what I'm trying to, right? So the load balancer and the web server both are within the VPC, both are within the AWS control, both are actually can connect over the private network, because the LB and the web server both are deployed it into the same VPC. They can communicate via the local gateways, as we know. So I don't need to worry much about it. But the communication between the client and the load balancer, which is actually happening over the public internet space, so we need to ensure that the security is enabled between the public client and the load balancer. That's more important. If you want to enable the end-to-end encryption start from client to web server, that is fine, but right, mostly between the LB is more concern point. So hence the reason now, rather me setting up these keys in the web server level, I'll set up the keys at a LB level, correct? Make sense? I'm not putting it at a web server level. I'll keep it in my LB level because I'm expecting the encode and decode process between the client and LB only, not from LB to a web server. So based on the requirement, you need to decide how you wanted to configure the certificates and all these things. And to make it more easier to enable the SSL certificate between the client and the load balancer, all what you need to do is right, go to AWS. Okay, AWS is actually providing the SSL certificates for you, right, with the help of this certificate manager service. Right, this is the certificate manager service, and this is where I can go and request for the certificate. You see this? Hey, I need a certificate. I need a public certificate that I wanted to use for my website. Just go to next. Then it is asking you, hey, tell me you need a certificate for which website. Remember guys, the certificate that you are going to purchase, right, that certificate must be valid for a specific website that you have been purchased for. The certificate that I have purchased for edshopper.com will never work for any other websites. That's the reason you must specify here for which website that you wanted to use this certificate. Then that certificate will work only for this website, not for any other. And again, if you are purchasing a certificate for edshopper.com, it will work for edshopper.com. It will not work for, let's say, test.edshopper.com. No. If you purchase a certificate for www.edshopper.com, it will work for only this name, not for any other. So you completely give your name here, which name that you are expecting the clients are accessing, and your certificate to be, right? So if you say like, no, maybe I wanted to have the certificate which will be working for any of my edshopper.com, you can even go for like this start.edshopper.com, so that before that shopper it can be anything. That's what you are saying. So like that we can configure the things, but for now let me give www.edshopper.com. Now, can I buy a SSL certificate for the domain where the domain is not mine? Let's say I'm not the owner of the domain. Can I purchase a certificate for that domain? Ideally, you should not, right? Correct. That is the reason whenever you are trying to request for the SSL certificate for a domain, it will ask you, hey, you need to validate that the domain is yours. You prove that this particular domain is actually purchased by you. You are the owner of the domain. You prove that, then only I will issue the certificate. That's where the validation is mandate. Right? We can do a validation in a multiple ways, email or DNS. So I will go with DNS validation for now. You see now, the key algorithm is RSA. Same thing, like these are the SSH keys, nothing much. You can choose any type that you like it. Just go to request. You see now, it is now waiting for the validation, guys, because we need to prove that the domain is yours. How to do that? So to prove that the domain is yours, so we need to create a CNAME record in your, in your domain. So go back to Route 53 now. It's a larger concept. Overall, what is that you need to understood, right? HTTPS is a protocol to have a secured web application accessible, and we need a SSL certificates to be deployed. The set manager is the service that will help to create a certificates, and we need to generate a certificate and use it. If you know these statements, that is good enough. You don't need to worry about how to implement it also, not a worry, because this is not a repetitive activity in a real time. It's like one-time job. Anyway, so take this resource name, create a record in the Route 53. This is already given. This is the value. CNAME record. This is the value. That's it. When you add this record, right, AWS will verify this, whether this record is successfully added or not. If then AWS will confirm that, okay, this is yours. Because you can create a record like this only if your domain is yours, right? Correct. Can I create a record like this for facebook.com? I can't, because that is not my domain. So if you are able to add a record like this, then that is a confirmation that the domain is yours. Then the AWS will start, issuing the certificate for you. It takes some time, guys, for validation. We need to wait for that. Usually AWS says that maximum it may take 24 hours as well to validate the certificate. That's okay. And it has a certificate ID as well. Once the validation is successful, you get a certificate. Once you get a certificate, all what you need to do is go back to your load balancer, right? Go back to your load balancer. Go to your listener configuration. As of now, I said that, hey, load balancer, you listen on 80 number and you forward to here, right? Now, I'll just add a listener saying that, hey, load balancer, you now listen on HTTPS traffic on port number 443. Whenever you get a request on 443, then you forward that request to a specific target group, and you please follow this particular SSL certificate. It should be here. You see that? You should get a certificate here. As of now, it's not showing for me to select it from the drop down because the certificate is not yet issued. It is still waiting for the validation. You see this? Correct? Once the certificate is issued, then you should be able to get it from the drop down here. Select the drop down. That's it. Go on, click on add. We are done. Now it should take care of everything. How to make it encrypted and how to make it HTTPS traffic between the client to the server. Okay. So if you are not able to complete this SSL certificate lab, that is still be fine. Understanding this concept is enough for now, because I'm going to improvise this process a little more better way in a Kubernetes again. So we'll focus more on that Kubernetes, because that is what actually the thing that the people are using in the real time, right? All whatever I'm discussing today will again be revamped into a different way, guys, in order to improvise the process when I'm reaching towards the Kubernetes. Kubernetes is our end goal. Yeah, but yeah, this is how it works. So any questions to me on this today's section, please do let me know, or else we are good for today, guys, because we don't know how much time that the AWS takes to generate a certificate. So that is still be fine for now. So that's the story for today. I hope you got the wonderful insight about all the concepts for now, because we talked about all the topics that we talked about in AWS, right? Everything is integrated into one single session today almost, right? That's where we touch base with everything: EC2, Route 53, CloudWatch, SNS, VPC, all the concepts. Any questions?